So welcome to today's class. We are going to begin the first chapter of CCNA 2, that is routing, switching, and wireless essentials. And the first chapter is called basic device configuration. Basic device configuration. And just to start us off, before I get into this first chapter, I would like to introduce us to what to expect in CCNA 2. What are we going to be expecting in CCNA 2? Okay. And so I'm going to bring up the chapter 2 here. It's called switching, routing, and wireless essentials. And I'm going to just zoom it here. All right. And so here we are going to cover a couple of topics here. The first topic is basic device configuration, where we'll do the basic configurations for routers and switches. We'll study switching concept within the switch environment. Then we'll get to chapter 3, which is called VLANs, the virtual local area networks, VLANs, and how do VLANs communicate within the same network. Then we'll move to communication between one VLAN and another VLAN, what we call inter-VLAN routing. And this is normally done using a router or a layer 3 switch Then chapter 5 is STP concepts, spanning tree concept. Every switch must have a spanning tree instance, and we'll talk about what is the importance of spanning tree within a network. Then we go to what is called an ether channel. Ether channel, bundling several physical links together to work as one logical link. Majorly, this is used to increase the bandwidth between two devices, mostly switches, but even routers have a certain level of ether channel, referred to by a different name. Then we'll talk about DHCP for this module, Dynamic Host Configuration Protocol. This is the protocol that leases IP addressing information to our end devices. You know, we can't manually configure our end devices. We can make mistakes. We can repeat the same IP for the same devices. So to be organized, we'll be learning how to configure DHCP server. And we'll actually learn how can we configure a Cisco router to be a DHCP server for at least one network, or 2 or 3, by creating DHCP pools. Under the same topic for DHCP, we'll also learn how to configure a router to become a DHCP client, such that a router can also receive IP information from a DHCP server. And then we'll also talk about how do we configure a router to be what is called a relay agent. How can a router relay DHCP request information from one network to another network? That is all you learn in chapter 7. Chapter 8, we are going to learn how DHCP happens in IPv6. And that's called DHCP-v6 for IPv6. And we'll talk about something called SLAC, which is something we had talked about before. SLAC is stateless address auto configuration. Okay. And then we will talk about chapter 9, FHRP, the fast hop redundancy protocols. This is a technology which allows us to have more than one default gateway in a network. You know, every end device can only accommodate one default gateway IP address. So if that default gateway ever goes down, how are we going to be able to still access the internet by using a redundant default gateway? So we're going to talk about that within the FHRP concepts. And FHRP, the fast hop redundancy protocols, is basically just a group of protocols that do that job. And we'll go specifically, we'll talk about HSRP, which is the hot standby router protocol. Of course, we have VRRP, we have so many of them, like GLBP, Gateway Load Balancing Protocol. Then we're going to proceed to chapter 10, which is LAN concept, LAN security concept. We'll talk about some of the major security issues that we find within the LAN, especially at layer 2, all right? And we'll also learn about how do we configure some of those layer 2 protocols. Like that will take us to chapter 11, where we'll talk about switch security configuration, where we'll talk about a concept called port security. In port security, you can configure one port to accept, being connected to one computer or two or three, and we can configure security at the level of the port. That is port security as chapter 11. Then in chapter 12, chapter 12 and 13, we will talk about WLAN, that is wireless local area networks. And we'll talk about the different types of wireless local area networks. And we'll also do some bit of configurations for this particular chapter here. Chapter 14, we'll now get into this. Actually, from chapter 14 to 16, we will be talking about routing, because routing is such an important part of the network. And routing is the process of forwarding a packet from one network to the other. And that can be done using a router or a layer 3 switch or a layer 3 switch. So we look at routing concept. We'll talk about the routing table. And you know that routing is always divided into two. We have static routing and we have dynamic routing. So for this last part of this module, we will configure static routing and look at the different ways of configuring static routing, including things like the next hop IP addresses, the exit interfaces, or the fully specified, where you mention both of them. And then we conclude this module by troubleshooting static and default route. Very, very important. So we look at the different types of static routes, and it is very interesting that the second module, CCNA 2, switching, routing, and wireless essentials, it ends with routing, and the last module, CCNA 3, begins with routing, where in CCNA 3, enterprise networking, security, and automation, will now begin with dynamic routing, because normally we have two types of routing: static, which we'll study at the end of CCNA 2, and dynamic, which we will study at the beginning of CCNA 3. And so we, of course, will give a brief overview of both of them at chapter 14, where we'll talk about the different routing concepts. So that's all that we'll be covering. This is now 16 chapters, and it's going to be very interesting, guys. Most of the those protocols I've talked about, we're going to be configuring them within this particular chapter. So for now, let's go back to our first chapter. Let's go back to chapter number 1, and let's see what's chapter 1 is having for us. All right. So I'm gonna just zoom this in again, back to 100%. Yeah. So let me bring up my PowerPoint here, and let's kick this off, ladies and gentlemen. All right. So for this first chapter, we are going to configure switch with the initial settings, configure switch ports, secure remote access, basic router configuration, and verify directly connected network. So to start us off, we start by talking about what's called the boot sequence of a switch. So when a Cisco switch is powered on, when a Cisco switch is normally powered on, it must go through the following steps. And step number 1 is what's called the POST, the power on self-test. Okay, so the POST is actually a program normally stored within the ROM. And that reminds me of something. We normally have 4 types of memories. You might want to note that down. 4 types of memories found in these devices. The first one is called the RAM, the random access memory. That is the first memory, the random access memory. So the random access memory Where is it stored, or what is stored in the random access memory? Okay, the running configuration file. The running configuration file is stored in the RAM. The second memory is the NVRAM, the non-volatile random access memory. So in the NVRAM, the file stored there is called the startup configuration file. So the startup configuration file normally is stored within the NVRAM. The third memory is called the flash memory. The flash memory. And the flash memory, we store the operating system, the Cisco IIS. The IIS software is stored in the flash memory. And finally is the ROM memory. The ROM memory normally is the boot up instructions, okay? The boot up instructions are always stored in the ROM, the read-only memory. So the read-only memory, that's where the boot up instructions, including the power on self-test program, is always stored there. Okay, so that is very, very important for us to note. Now, let's go back to the boot sequence. So first is the power on self-test program, which is loaded, and the post will check the subsystems for the CPU. Okay, and it will test the different type of memories there, the CPU, the DRAM there, portions of the flash memory, and all that. So once the post is loaded to check those types of memories, then we have the switch is going to load the bootloader software. The bootloader software, which normally is a small program, still stored in the ROM. You realize these are the boot up instructions. These are the boot up instructions still stored within the RAM, within the ROM, the read-only memory. Okay. Then the bootloader will perform some low-level initialization of the CPU, and it will actually initialize the CPU registers, because these registers, they're the ones that control where the physical memory is actually mapped. They check the quantity and even the speed of the memory. Okay. Then the bootloader is going to initialize where the operating system is stored, the flash memory, the flash file system stored in the flash memory. And finally, the bootloader is going to locate and load the operating system, which will now take over the running of our device. It will take over the running of the switch or the router. So that is important for us to note. So this is what is called the boot sequence that we have in our router or the switch. Now, talking about the switch here, this is the front end of the switch. Normally, this is the front end of the switch. And the switch normally has some lights. We call them the LED light, the light emitting diodes lights. And they are very important, especially for troubleshooting. And you can see the first one is actually SYST, the SYST LED. That is a system LED. Normally shows whether the system is receiving power or not. If it's receiving power, then it's functional. It's functioning properly. If it is off, then that means your device is not receiving power. So you need to check your power system. Then we have the RPS, the redundant power supply. This will show the RPS status. These switches, they can use more than one source of power, So if the RPS status is showing or is shining the light, then it means that the RPS status is actually okay. Of course, we have the port status, LED, and you need to note that the ports will always, these lights will always indicate different lights to communicate to you. For example, in most cases, green is a good sign. Okay, sometimes it will be green and blinking, or just green, and sometimes you need to count the blinking. Is it blinking once and a pause, or blink twice and a pause, or blink thrice and a pause? All right, and that of course takes us to the port speeds and the DUPLX. which is the port duplex LED. Most switches nowadays operate in full duplex, okay? And so when it is green, it indicates that the port duplex is actually selected. For the speeds are actually indicated by the number of blinks. So for example, 10 Mbps will have one blink and a pause. 100 Mbps will be two blinks, and 1000 Mbps should be able to give us three blinks and a pause, all right? Not all switches though, but some switches will also have an LED called the PoE. PoE is just the power on self-test. Power over Ethernet. And so PoE is important for gadgets like access points and voice over IP phones and web cameras. Those are gadgets that they do not use their own power supply. So they actually get power from the switch. So the same Ethernet cable that connects from the switch to any of those devices will also be powering those devices, so that the gadget shouldn't be having a power cable, to give it power. It gets power from the same Ethernet cable that connects it to the switch. So normally switches with the PoE port are more expensive than those. Okay. Now, so we had talked about, of course, the switch management access. And to switch management access, we did talk about the console port and the console cable here. And we say that the switch comes with one VLAN port, and we were able to see that it is actually normally VLAN 1. That is the only port that can be assigned an IP address. And I said that that VLAN port, the moment you sign an IP address on it, then it now becomes what is called an SVI, switch virtual interface, okay? And that is a port that is supposed to be assigned an IP address. Why is it assigned an IP address? Because that IP address will be used for remote management. And that's why that port is normally called a management port. We always call it a management port, okay? Because you use that IP address on that port to manage the switch remotely. Remember, for the layer 2 switch, the only port that can be assigned an IP address is the VLAN port. All the physical ports from F01 to F024 and G01 and G02, those ports cannot be assigned any IP addresses. Very, very important to note. So normally, you're supposed to configure the management interface with an IP address and activate it. And as we'll be learning soon enough, the default name of that port is always VLAN 1. But that VLAN 1 normally has some security concerns. And for security purposes, we need to change that. We need to create a separate VLAN other than VLAN 1. And that is something we'll be talking about soon enough. We'll create VLANs and we'll be able to see how that works. And so once you create the new VLANs, let's say VLAN 99, you need to activate it and then assign it an IP address, and you no longer have to use VLAN 1, okay? Now, most layer 2 switches can only accommodate IPv4 addresses. But there's this command down here. You can use it to make your device to accept both IP version 4 and IP version 6. So at the global configuration mode, you're going to put the command SDM. Yeah. SDM, just a minute. Let me just take a pointer here. Place a pointer. Yeah. So say SDM prefer dual hyphen IPv4 hyphen and hyphen IPv6 default. Once you put this command, then you're gonna need to reload the switch. And when you reload it, the switch is now going to accept both IPv4 and IPv6. So that is very important for us to note. All right. Now, we do have this basic SVI configurations found on the switch. We get to configure terminal, we get to interface VLAN 99, give it an IP address, give it IPv6, activate it using no shutdown, and command end to take you to the privilege exec mode, and then you put the command for saving your work. You guys might have forgotten this, but you need always remember this. But I'm also going to do some demonstrations here for you guys to see, okay? Yeah, so I'll be able to go through this again, and you'll be able to configure both IPv4 and IP version 6. For the default gateway, of course, we also need to know how to configure the default gateway for our switches. The switch and the PC are the only two devices that need to be configured at the default gateway. And the command for configuring default gateway is IP at the global, IP default hyphen gateway 172.168.17.99.1. 172.17.99.1. So the default gateway is not configured with a subnet mask, and it is not configured on an interface. It is normally configured at the global configuration mode. Then you're gonna need to save your work, copy the running configuration file into the startup configuration file. Right. Now, let me see if you can do a few of those configurations here, just to be on the same page here. Let me see if we have. Okay. I think we're going to work on it later on. These are for switch port and SSH and all that. Yeah, we'll come here for these ones here. Let's continue just with the PowerPoint a little bit, and then we will of course just come back to that. Now, so we have these commands: show IP interface brief, and the IPv6 version of the command is show IPv6 interface brief. Very useful to know the status of both your physical and virtual interfaces. And it's a very important command, that you always need to know, okay? And so you realize that when you say show IP interface brief, we have our I interface here is VLAN 99. The IP is here 172.168.99.11. It's okay, yes. The IP has been manually configured, not by DHCP. Look at this. The status is currently down. The status is down and the protocol is down. It means we have not said no shutdown on that particular interface. And you could also see that with IP version 6, whereby when you say show IPv6 interface brief, we are also able to see that it is in down state. All right. Now, for the sake of this switch configuration, switch ports can always be configured with several things. And one of the things that can be configured on the switch port is this duplex and even the speed. Okay. Remember, we have port speed and we have link speed. Those are two things that you should never confuse. So this is an interface speed. If two switches are connected together, you need to set the speeds to at least be the same on the ports. Okay. So when you get to interface such as interface first Ethernet 0/1, okay. Remember, duplex is either full or half, okay? And you need to put the same duplex mode on both sides of the switch, otherwise you'll have problems within the network, okay? If they are different, you might have some bottlenecks within your network, and that is not what you want. So set the duplex speed to full. Duplex mode is full, and the speed is 100, okay? And do that on both sides. And best practice, always copy. Of course, the command N or Control Z takes you to the privilege exec mode. Okay. Now, I don't know whether you can remember. We have talked about this before. The auto MDIX, automatic medium dependent interface crossover. When we were talking about the network media, we did talk about auto MDIX. Remember when we talked about copper crossover used for connecting same devices and copper straight through used for connecting different devices. Now, if you don't want to get into the business of creating either a copper crossover or straight through, then you might want to basically just configure auto MDIX, automatic medium dependent interface crossover, so that the cable will be sensed by the port and it will automatically configure or adjust the two devices to communicate along that link, whether they are same devices or they are different devices. Setting this feature enables you to use any type of cable to connect your devices. So that is very, very important. Now, it's also important to note some show commands, verification commands here. I know we have been talking about show running config, but we also have show startup config to view the startup configuration. Show flash and show flash will give you, of course, the file systems. A very important command is show version. Show version displays so many things: the hardware properties of your device, the serial numbers, of your device, the version of the device, and even the memory. So show version is a powerful command, and they even ask it in the exam sometimes. Show history will reveal or display the commands that you have entered before. We have show IP interface brief or show IP interface, show IPv6 interfaces, show MAC address table. Of course, that displays the MAC address table. It is very interesting that remote access is something that you can never separate from. Every time, every network administrator, you need to do some kind of remote access, okay? And like I said, this has always been done using SSH and telnet, SSH and telnet, all right? And so, talking about remote access, you can never talk about remote access and don't talk about these two. Telnet uses a TCP number, port number 23, but telnet is a bit older and not secure because everything is sent in plain text, and that is not what you want. Using a software like Wireshark, you can actually be able to see everything that someone is doing if they're accessing the device using telnet, and that is if they are not using any VPN, okay? Because if you use a VPN in your network, then it means everything is actually encrypted, like in SSH. So if you need security, then you're gonna need to use SSH, the secure shell, which uses TCP port 22. So it encrypts all the interactions that you're doing between your computer and the remote device, and it provides some kind of security for the remote access you're doing. And both of them, you, of course, must always put a username and a password to be able to log in to that device remotely. And looking at this diagram here, we can see that SSH is has encrypted everything. You cannot read anything like that here. If you looked at the previous diagram and I zoomed it in, you realize that here we can see that the username is admin, even if they're a little bit vague or blurred. You can see the username is admin and the password is actually CCNA. This is not what we want to see in SSH. You can see in SSH, everything is actually encrypted and you can never know what exactly is being accessed. How do you configure SSH? I will wish to take you through this in a protocol in a in a practical form so that you can be able to follow the steps. So, let me see what to do here. Let me, okay, these steps, we have about 6 to 7 steps. Of course, the first thing is to verify if the device can support SSH. And secondly, you need to configure the domain name. Then you need to generate the encryption RSA keys. Then you need to this is generating the keys. Then you need to configure the users who are going to use SSH within your device, or who are going to access that device within SSH. They need to configure SSH within the lines, enable SSH on line VTY immediately, and then need the second version of SSH. So what I want to do is I would like to do that practically, so that we are not just learning things for the sake of. All right. So let me just let me bring up this, and I'm gonna bring up that packet tracer there so that we can be able to learn. Correct. Yeah, so this is a very interesting one. Let me just dock it up here, and we're gonna configure SSH in a very interesting manner. This is packet tracer 136. I'm just zooming in here so that you can be able to see my 2 devices. So look at this. I'm having a switch here and I have a PC1 here. And I'm gonna configure switch S1 so that we could access it from the PC through the network, okay? So on the instructions, they want us to get into PC1 and telnet to the switch. The passwords for the 2 devices for the logging in, user and privilege is actually Cisco. All right, so let's go to here, open the switch, the PC, go to the desktop and go to the command prompt. And it's simple. To access, remember you are in the PC. We're in your PC, in your CMD, okay? Let me just move it the other side. All right, so we are in that PC here, and we want to access the switch through the network. So just say telnet, and I put the IP address of the switch, which is 10.10.2, 10.10.10.2. And I press enter. There you go. The password they told me was Cisco, but the password. And look at that. I'm already in the switch. Okay. And I can do enable. And the password should be Cisco still. And I'm at the privilege exec mode. And I could say show run just to be able to see what is found here. I can see the host name is S1. Enable password was Cisco. And I continue pressing the enter key to see my 24 ports for fast Ethernet and 2 gigabit Ethernet ports, gigabit Ethernet 1, 0/1 and 0/2. My SVI is here, configure the IP address, and this is the IP we are using to remotely access this switch. It is the switch management interface, switch virtual interface. So you can see the line VTY password is actually Cisco, and that's it. Now, the instruction further says that, let me just get this clearly here. The instruction says that we need to save the current configuration so that any mistakes we make can be reversed by toggling the power on switch. So to save our work here, we say copy running hyphen configuration, startup hyphen, configuration and press enter, and we have saved our work. Then show the current configurations and note that the passwords are in plain text. We have seen that. We need to encrypt all the plain text passwords. And you people know that we need to go to the global configuration. You see, you can just say conf t and you say service password hyphen encryption, and we have encrypted all the password. We need to verify they are encrypted. You say we can, if you don't want to go to the privilege exec mode, I need to start teaching you this now because you are in level 2. You can just use the command do. Because all show commands are always put at the privilege exec mode. But if you don't want to be going back to the exec mode and back, there is a shortcut by just using the word do. So you start with the word do and then type your show command. So say do show run to show run, and you can see our passwords are now encrypted here, and the enable secret, I don't know where the enable password is there, and the passwords, you can see the user exec mode passwords are also right here. Okay, now we then need to encrypt our communications to configure SSH now. So we need to set the domain name to netacard.pka. So how do we do that? The command to set the domain name, we say IP domain hyphen name, we say netacard.pka, netacard.pka, and we press enter, and we have configured the domain name. It could be something simple as facebook.com or google.com or ku.ac.ke, any domain name. All right. And then we are told to secure keys, that the secure keys are needed to encrypt the data. So we need to generate about 1024 key length. How do you generate the encryption keys? It's a long command here. We say crypto key generate RSA. Now, this command can be shorter or longer. You can stop there and just press enter. All right. And it will ask you to input some value there. And I'm going to put there 1024. I'm going to put there 1024. I'm in a meeting. I'm going to call you later. All right. So I could type there 1024 and press enter, and the keys have already been generated, 1024 encryption keys. So like I said, that command can have two variations. If I don't want to press enter and type everything on the same line, I can continue and say crypto key generate RSA. Then we say general hyphen keys modulus, then you put 1024. So I'm typing the whole command here. Let me just make it long enough for you to see this command. You can see it, crypto key generate RSA, general hyphen keys modulus 1024. Type everything on the same line. So initially, you'll find the first one very easy. Crypto key generate RSA, press enter, and put 1024. But if you do it this second method, it's still the same thing. All right. Then we need to now create the usernames and passwords. All right. So we're told there's a user called administrator, and his password is Cisco. So we say username, and it's administrator like this, administrator. And the secret part we say secret is Cisco. Sometimes they also add here a privilege. We'll say privilege, maybe 15, okay? But this will come later on. Username, administrator, that is the name of that person. Whatever they want to log in, they must put that name. And the secret is Cisco, so his password is Cisco. We can create another username, say username is Nelson, okay? We give nation maybe privilege, maybe give him privilege 0. And you say secret, you say the secret for Nelson is gonna be Nelson at domain, okay? Nelson at domain, at symbolizing A. So that will be a secret, so that every time Nelson needs to log in, he must use his username and he must use his password, which is the secret there. And so I just press enter, and you can create as many usernames as possible as you want. If you have 5 people in the department, you create each and every person, you give them their own username and password. So they want to log into the switch remotely, they want to log into the router, they can just do that. All right. Once we create that database of users and passwords and privileges, then we now need to enable SSH on the VTY lines. Remember, VTY lines are the ones that are used for remote access. VTY means virtual teletype. All right. So we need to set the VTY lines, check the local usernames, and we need them to do what? Let me just reduce the size of this one here to be able to read what's happening here. All right. So we're told to configure virtual lines to check the local username database for login credentials and only allow SSH for remote access. We need to remove the existing VTY line password. So let's do that one at a time. So line VTY 0 to 15, example, enter. Because we always say here, password Cisco. We can say no password. We are told to remove the password in the line VTY. We're also told to use it to check the local database for login. So you say login local, login local. You're telling it to log in using the local database of usernames we have created locally here within this device. And I want you to mark that very, very importantly, guys. We have created usernames and passwords locally in the device. Remember, you also have an option to create the usernames and passwords outside of your device using a technology we call the AAA, the authentication, authorization, and accounting server. All right, so we are turning the device login using the local database. So login local, all right. And then we need to allow only SSH. So we say transport input. We could say SSH. We could also add telnet here, okay? If you see it here, telnet, and you could add maybe SSH or something like that. So here we are told to only, we can see the different options. We can allow all of them. We can allow none. We can allow SSH or telnet here. So we are told to only permit SSH. We say SSH, transport input, SSH. All right. Then to conclude this, we need to verify that SSH is actually working. So we need to exit this telnet session. Let's look at it. Look at this one. This is important, guys. Remember, we logged in using telnet onto our switch. And now we are being told to exit the telnet session. We are actually currently configuring this device remotely using telnet. But telnet is not secure. So we have been told to exit the telnet session and attempt to log back using telnet, and to see what's going to happen. I'm gonna exit all through, exit again. And I've lost connection. You can say connection to 10.10.10.10.2 closed by a foreign host. And remember, we had used this command to telnet into the device. I can press enter, and you're told the connection has been closed by a foreign host. All right. It means this switch has been told to only accept SSH sessions, not telnet anymore. So to log in or to get in using SSH, we're going to type SSH. It's a bit detailed than the telnet one. C-L, that is a small L, and the L means login. Then we need to put the username, which was administrator. Then you need to put the IP address. It's 10.10.10.2. And look at that. It is asking us to put a password. And the password we had put, if I don't forget, was Cisco. Remember, you cannot see the password when you're typing it, and that's a security mechanism. We have successfully logged in using SSH, and you could say, show run. And you can see our long password is here. Very, very secured there. Our domain name is actually here, netaka.pka. Spanning trees, of course, there, and the 24 ports for fast Ethernet and the 2 gigabit Ethernet ports are actually here. Our switch virtual interface IP address, of course, is here. All right, and the configuration for SSH transport input SSH is here, and that's it. So we have been able to successfully configure SSH, and we have been able to do. Let's log in using the previous, the other user. Remember, we are configured 2 users. One was called administrator, and the other one was called Nelson. So let me see Nelson. So Nelson. What did I do here? Should be capital N. Nelson. And there we go. And password was Nelson at the main. And there we go. You realize something here. I don't know that you can. When we logged in using administrator, it took us straight. You can see it here. It took us straight to the, look at it here. After I put the password, it took us straight to the privilege exec mode. We didn't need to put any password. Look at that. Because the administrator was having privilege of 15. Now we gave Nelson a privilege of 0. Look at where it takes us. To the user exec mode, we must say here, enable, enter, and you must put a second password, which was Cisco. This is very funny. So I'm trying to demonstrate to you the importance of privilege in a network. You give a lower privilege, they're gonna need to use a second password to log in. If they don't have it, they're doomed. They can't log into the device. You give them a higher privilege, they can log in without being required to put a password, and many other things. We'll talk about the privilege later on. So that's how to configure SSH. Very, very important. Remember, this is work in progress. We are still going to be configuring SSH later on with more settings. All right. So that has been SSH for us. And let's just continue with our learning here. So you could say show SSH. Those two. The only thing we didn't configure, I think, was let me just do it before you guys forget, or before I forget. You need to, if you say here, show SSH. Show, okay, do show. You see the current version of SSH that we are dealing with here Look at this. Look at this. Look at the version, guys. Version 1.99. If you are a mathematician, you will round off this to be 2, but that is not the case. This is actually version 1. All right. You can see SSH version 1 server is currently running. So to make it to version 2, we need to say IP SSH version 2. All right. And when you say do show, you can now say, let us say again, version 2. Okay. It's confusing me here. Okay, let me just see here. Oh, it's telling me no SSH version 1 server. Connections running. Show IP SSH. Do show. Yeah, you can see SSH enabled is now version 2. Version 2 is currently running. Yeah, but anyway, we will talk more about the versions later on, and just to be able to make us to understand. Yeah. Now, moving forward, we're going to look at the basic router configurations, and these are things that we have actually talked about. We don't have to discuss so much about them. I just want to give a brief demonstration of this. I think that this dual topology, which is carrying both IP version 4 and IP version 6. Of course, I hope you remember how to count the number of networks here. 2 routers. Each router is directly connected to 3 networks. Router R1 connected to 3 networks. Router R2 connected to 3 networks. And router R1 and R2 are directly connected with another point-to-point network here. So this is one network. Let me just get my pointer. So the interface of a router is always the determinant of how many networks are there. This is one network. This is another network. Even if they have 1,000 switches here, this is one network. This is the third network linking R1 and R2. This is the fourth network connected to S3. And the fifth network actually, no, the fifth network, yes, connected to S4. Now, the reason why I call it a dual stack topology is because this topology, you can see it has both IP version 4 and IP version 6 addresses. And we want to configure them right here. You need to see a few things here. An interface of a router can carry both version 4 of IP and version 6. So you need to get into that interface, gigabit Ethernet 0/0/0. Give you the IPv4 address. You say IP address 192.168.10.1, 255.255.255.0. Then IPv6 address 2001:DB8:1:1//64. You need always to describe your interfaces. This is the command is here. Description, what follows after the command is your own wording, the way you like to describe. Like this one is using link to LAN1. Some people like saying connection to LAN1, whatever it is. Activate your interfaces, very important. Then you can get out of that interface if you want to, or you can go straight to another interface saying interface gigabit Ethernet 0/0/1. Same way, assign it an IP version 4 address with a subnet mask, give it an IPv6 address, describe it, link to LAN2, and then activate the interface, so on and so forth. Okay, and you can as well configure serial interfaces. interface serial 0/0/0. Those are different router interfaces. IPv4, so you say IP address, give the IP and the subnet mask there. IPv6 address /64 there. Describe it. Description is not a must, but it's very, very important, very necessary. You only realize it's important when you need to troubleshoot. You don't know that interface serial 0/0/0 is connected to which router. You don't know gigabit Ethernet 0/0/1 is connected to which device. So you don't even know where to start when you're doing troubleshooting. So make sure you describe every interface and you're gonna need to activate it. Okay. Now, just like we have virtual interfaces in a switch, the VLAN interface, routers also have virtual interfaces. And one of those virtual interfaces is called a loopback interface. Loopback interface. A loopback interface is a virtual interface created within the router. The moment you create it, that interface normally goes to up state. Without you saying no shutdown, it already goes up. There are protocols like OSPF, the Open Shortest Path Fast, which normally prefer using loopback interfaces. And soon enough, I'm going to explain to you why is it that it prefers to use SPF. I mean, it prefers these loopback interfaces. Once you create it, okay? Once you create the loopback interface, assign it an IP address just like any other IP address, saying IP address, submask, and IP address there, and even IPv6, okay? And today we're gonna create some loopback interfaces. Don't worry about that. So let's do some configurations here. Let's do some configurations here. All right. So let me grab some work here to be done on our router, and yeah, we do the basic router settings here, and I can just zoom this in to be able to. Let me remove these ones. Let me zoom this in. All right, so this is well visible now. And we need to enter the global configuration mode. We're told enter the global configuration mode and name the router R2. All right, so we say here there are no shortcuts. You must type the command as it is. You say configure terminal, enter. We need to name the router R2. So say host name R2, correct? You need to create a class as the secret password. Enable secret class, correct? We need to configure Cisco as the console line password. Require users login, then exit the line configuration mode. So get into the console line, console 0, enter. Password, Cisco, enter. Require login. Require users login. The command is just login. Then we exit this level, enter. Then we told configure Cisco as the V2I password for line 0 through 4. Require users to log in. So as usual, line V2I 0/4. We need to give it a password of Cisco. Say password Cisco. All right. Then we say login. Require users to log in. Correct. We need to exit this line configuration mode. And we need to encrypt all the plaintext password. We say service password hyphen encryption. All right. Then you need to set a banner here. Authorize access only with an exclamation mark. And you're using the hashtag as the delimiting character. To say banner MOTD put our delimiting character with shift 3, two of them, and say authorized with a Z, access only. You must type it exactly how it is. Where there's a capital letter, you might want to make sure you do it that way. Then you press enter, and that's good. We need to exit this configuration mode and save the configuration. You say copy, running -config space startup -config, and we are good to go. Those are basic settings of a router. Okay. And having done that, I want us now to configure IP addresses on these router interfaces. And that's what's going to be doing here. All right. So we are given the first interface, gigabit Ethernet 0/0/0. We're told to use the short form of G0/0/0. So we are ready at the global configuration mode. We are told to enter. So we say interface G0/0/0. We give you the IP address of that one. Say IP address 10.1.1.1 space subnet mask is 255.255.0. We give the IPv6 address. Instead of saying IP address, we now say IPv6 address 2001, DB8, a card. Remember, they're always case insensitive. So you can type capital or small letters, it's okay. :4, :1/64. Enter. We need to describe the link as link to LAN 3. We say command is description. Then you say the description is in capital L, link to LAN 3. All right. Then you need to activate the interface. These things can be in any order. It doesn't matter. See, we can even start with the no shutdown. Say no shutdown. And press enter. That takes us to the second interface, which is interface gigabit Ethernet 0/0/1. You can enter the full command, but in this case, we are told to use the short form. We say interface G0/0/1 IP address 10.1.2.1 255.255.255.0 IPv6 address 2001 :DB8 :a card 5 :1/64. Then we say we describe the link description link to LAN 4. So this interface basically connects the network, the router to LAN 4. Enter. Then we need to activate the interface. You say no shutdown. You must put the command here in 4. Oh, there's another interface here. You say interface, wrong spelling here. S0/0/0. Remember, I use a small s. If you use a capital S, I think it's gonna penalize you. So we put the IPv4. We say IP address 209:165.0 200, not colon, dot 226. And the subnet mask is /30 255.252. IPv6 address is 2001 colon DB8 colon ACAD colon 3 double. Be very keen. 226/64. Be very keen with IPv6. It's very easy to pick the wrong one. Okay. Once you've done that, then we need to describe the link. So description link to R1. And you say no shutdown. No shutdown. And you're good to go. All right. Very important. Please find time to be practicing these ones. You never know you know it until you do it. All right. So this is on page 145 within your account. Page 145 within your account. Loopback interfaces. Let me check if there's a router here. I can just bring a new router here and mount it here. I want to show you guys how to create a loopback interface. So if this is my router, it's still booting. Yeah, there we go. So let me see, once it finishes the boot, it will be done in seconds here. You might know, you really want to type no or end there. So what I want to do is interface. I want to just test something here. Loopback. I wanted to show you how many loopback interface can you create, virtual interfaces. If you can read this number is 2,145,483,647. That is the number of loopback interfaces you can create. Over 2 billion, 2.1 billion loopback interfaces. Those are virtual interfaces. They're actually more than that because it starts from 0. So to create a virtual interface, very easy, just say interface loopback 0. And the interface is already there. Okay. We could say interface loopback 1. It's already there. We could say interface loopback 1,000, 1 million. Yeah, I could create that so that if I say do show IP interface brief, realize I have my loopback interfaces here. Let me just expand this so that you can see them. I've created loopback 0. I've created loopback 1. I've even created loopback 1 billion here. And these interfaces, even without saying no shutdown, all of them, the status is always up and the protocol is always up. Very, very important. And we're going to talk about them soon, but they're very important. You can create as much as over 2 billion addresses. That's interfaces. That's a large number of interfaces, large number of interfaces. Of course, it's important that you know how to verify, your addresses. Okay. And so I just want to let me just increase. We need to just get done. We'll be done in a short while, guys. So, all right. So in terms of verifying connectivity, these are your show commands. These are normally your show commands. Show IP interface brief, or the show IPv6 interface brief. Show running configuration file, or show IP route to view the routing table. And these are commands we'll be using every now and then, okay? You'll be practicing to use these commands almost every day. Of course, we have the filter show commands. When you say show, for example, show run, it normally gives you so much details, all right? You can actually filter them to only view what you want to view. For example, if we go to our browser here, I could give you some show commands. Here we go. So we want to filter. Let's filter some of these commands. And so I'm going to just zoom this in to enable you guys to have a good view. All right. So enter the command to filter the show running configuration mode for the line con section. So you say show running -config. You use the pipe. The pipe command normally is found closer to your shift on the left-hand side of the keyboard. It's a straight line, which is used for filtering. So show running config, but I don't want to see the whole running configuration file. I just want to see small section here called line con. Only the line console. You see that? This is the running configuration file, but I don't want to see all of it. I only want to see the line console section. All right. We're told to enter the command to filter the down interfaces in the brief listing. You see, brief listing is show IP interface brief. We only want to put the pipe command. We only want to include only those interfaces that are down. Include down. So you press enter, and you'll only see the only interface that is down here, and that is going to give us that. That is serial 0/1/1. We can also filter the brief listing to exclude any interface that has up on it. So you say show IP interface brief, put your pipe command, and say exclude app. All right. These are things you see in Linux operating systems. All right, and you can see that we have excluded any that has up, which means you're only viewing the one that has down. Enter the command to filter the show running config output to begin with the word line. So show running -config, put our pipe command, and you say begin. You can't just use any word. I've used words like section, exclude, include, and now we're using begin. Any line that begins with any command that begins with the line. So that will be line console and line VTY. Very, very important. Of course, we have the command history, and you can see that, of course, on our slides here. We have already seen the filtering of the outputs, and of course the history command. We had talked about it. Normally, the history command is used to view, the previously used commands that we've used, and you can always use the up arrow key or the down arrow key. Now, so really, much of the work that we wanted to study today we already have, and I would like to just bring this class here right now, and that of course just marks the end of this chapter. We'll be starting serious work tomorrow when we are going to get into the switching concepts, and then we start talking about VLANs, the virtual local area networks, and we create VLANs and we communicate within one VLAN and between different VLANs, and we move on. Otherwise, thank you very much, guys, for listening, and you guys will have a good evening, and yeah, that marks the end of this class. So I'll see you again next time.